So we're going to talk a little bit about ideal gas law. And we needed to remember that ideal gas law is the combination of all the laws we had in the previous video. So it's a combination about Boyle's law, Charles, Gay-Lussac, Avogadro's. So when we combine all that once, we derive this formula, PV is equals nRT, and where P is equals to pressure, it's given in ATM or torque. V is the volume given in liters, N is moles, given in moles, units. R is a constant. R can be 0.0821 if we talk about pressure in ATM, or R can be 62.4 if we're talking about pressure in torques, and T is temperature, that is always in Kelvin. So P for pressure, V for volume, N for moles, R, it's a constant that can be 0.0821 if my pressure is in ATM, or 62.4 if my pressure is in torques, and T is Kelvin. So here I have one example. It says, what is the temperature of a gas if 4.3 moles occupy 74.1 liters at 739 torques? Okay, so the pressure is equal to 739 torques. Volume is equals to 74.1 liters. Moles, 4.30 moles. And what is the T? So, because my pressure here is in torques, I know that my R is equal to 62.4 torque liter over moles Kelvin. So now that I have, and I always like to write it down everything that the question gave to me, so it makes it easy to plug it into my equation. So I'm solving first my equation for T because I'm trying to find T. So I want a T by itself. So if I do that, I can divide this side for NR and divide this side for NR. So NR will disappear. So PV over NR is equals to temperature. Now that I solve my equation for T, I can just plug the numbers. So 739 times volume 74.1 divided by my number of moles, which is 4.3, times my constant gives me the temperature in kelvins. So doing this calculation on the 204 on T equals 204 kelvins. Kelvin. Okay, so basically I need to look at for my R and I say, well, my pressure is in torques is in ATM. If the pressure is in ATM, I use 0.0821. If my pressure is in torques, I use 62.4. Then I just solve my equation to whatever my question is asking for. In this particular case, it's asking for T. So I solve my equation for T, and I got that T is equals to PV over RT. Then I plug the numbers, and I ended up with my answer. Okay, another problem here. It says, what is the pressure of a gas if 2.05 moles occupy 61.7 liters at 71 Celsius? So let's erase this. Let's work this other problem. So I know that PV is equals nRT P, you want to know the pressure. Volume in this question is 61.7 liters. Temperature is equals to 71 Celsius. N is equals 205 moles. And R, you can use any one, because if you use this R here, you get your pressure in ATM, this R here, pressure in torques. The question doesn't specify, so I'm going to use the first one there. It is ATM per liters times moles per Kelvin. So I'm solving my equation for P. So I know that P is equals nRT over V. I just divided both sides by V, and I found P by itself. Another problem is that my temperature is in Celsius, but really I need to convert everything to Kelvin. So I added 273 here, and I ended up with, let me do this calculation really quick. 273 plus 71 gave me a 344. And now I can just plug my numbers in here. So my N is 2.05, write this down here. 2.05 times R, 0.0821 times T, which is 344, divided by V, which is 61.7. Okay, if I do this calculation, I ended with a pressure equals to 0.938 ATMs. So when they gave me a problem like that, we're talking about ideal gas law. We need to remember the formula PV equals nRT. I like to write it down on the left side of my paper, everything the question gives me. So I know I'm looking for P. So first of all, I will solve my equation for P. In this case here, just divided both sides by V. So I got that P is equals nRT over V. And then I plug the numbers. I know that the units for temperature needs to be kelvins. So I added 273, converting Celsius to kelvins. And then I plug the numbers, I run the calculation, and I got my final answer.